Hi, it's Mr. Anderson, and this is Chemistry Essentials video 20. It's on ionic bonding. Remember, ionic bonding differs from covalent bonding. In covalent bonding, they're sharing the electrons. In ionic bonding, what you're doing is you're transferring the electron from one atom to another. And so the quintessential example is sodium chloride. So sodium, here's its electron configuration, has one valence electron, and chlorine is going to have 7. And so if we look at their electron configuration, if we can actually transfer that electron from sodium to chlorine, then we get to this electron configuration that is a noble gas. It's going to be very stable. And so what we get is a sodium ion and a chlorine ion. And so the sodium ion, since it's lost an electron, we call that a cation ion. It has a positive charge, and the chlorine is going to be a negative charge. And the way I remember this, it's a little bit silly, but if you take that sodium ion, a cation ion, if you think of a cat has paws, and that means it's positive. Sorry about that, that's a little bit lame, but it's a good way to remember it. And so ionic bond is going to be between ions. It's a connection between ions. And so we're going to have a cation and an anion. Cations are going to be positive. That means they've lost an electron, and anions are going to be negative. And so what they form is something called an ionic solid. Now, how well that solid is held together is based on Coulomb's law. Remember, if we have a larger charge, there's going to be a larger attraction between those two molecules, or atoms in this case. And then the greater the distance is, the less the force is. And so if we have a really small ion and a large charge, we're going to have a stronger interaction. So it's important to kind of remember those two things. And so here's sodium chloride then. Sodium chloride is going to be all of our sodium ions. Those are going to be purple, which have a positive charge. And they're going to organize themselves in this real crystalline, nice solid. It's really high melting point, high boiling point. A super easy way to break it apart is with water, but it's going to be an incredibly stable kind of a molecule. And so what determines the stability, how well it's held together, is simply Coulomb's law. Coulomb's law, remember, if we have the same charge, there's going to be repulsion. And if we have opposite charges, there's going to be attraction. But if we look at the formula, the bigger those charges are, the greater that attraction is. And the bigger the distance, since this is the radius right here, the less that attraction is going to be. So let's throw sodium chloride up here. Sodium, which is going to be the cation, chlorine, which is going to be the anion. And then there's something called lattice energy, which just is a way to measure how well this lattice is held together. And so if we look at this right here, make a prediction. What do you think is going to happen when we move this from sodium chloride to sodium fluoride? Well, in each of these diagrams here, sodium is going to be this little purple sphere, and I try to keep that about the same size. But let's look at fluorine now. As we move to fluorine, can you see that that fluorine ion is going to be smaller? And since it's smaller, our lattice energy is going to increase because those ions are closer together. So let's go back to sodium chloride. What do you think is going to happen when we make sodium bromide? Well, the purple sodium cation is going to stay the same, but now since we've increased the size of that atom, we've decreased this lattice energy. And same thing as we go to sodium iodide. And so as it gets bigger, that distance between the two, just due to Coulomb's law, we're going to see a decrease in that energy between them. But what's the other thing that can affect it is the charge. And so if we run sodium chloride versus barium oxide, which is going to have a totally different charge, you can see that there's a great difference between those lattice energies. In other words, as we increase the charges, we increase that ionic bond between the two atoms. And so did you learn this to connect the microscopic structure to the macroscopic properties? It's simple. It's Coulomb's law. The greater the charge is and the smaller the distance between the ions, the greater the bond strength, and I hope that was helpful.